Problem solving in electromagnetic radiation. I am Dr. Buddhika Lenige. So today I am going to talk about electromagnetic radiation and some sample problem solving. So let's go and find out what is electromagnetic radiation. Electromagnetic spectrum. It is the continuum spectrum of electromagnetic waves with variable wavelengths and frequency. So in this given electromagnetic spectrum, there are different spectral regions: gamma rays, X-rays, this is ultraviolet, visible, infrared, microwave, radio and TV waves. So in this electromagnetic spectrum, you can see the one side energy and the frequency increasing, the other side wavelength is increasing. So energy and the frequency is moving together. If high energy and high frequency, then lower wavelength. Larger wavelength means lower energy and the lower frequency. So in this spectral regions, the gamma rays has the highest energy and the highest frequency. However, the lowest wavelength. And the other end, radio and TV waves, they have the lowest energy and the lowest frequency but high wavelength. The term we refer as light. Light is we refer for visible portion of the spectrum. This is the driven from wavelength 400 nanometers to 700 nanometers. This small portion we can see, we can detect with our eyes, not the other spectral regions. However, we have some applications of other spectral regions. For example, X-rays we can use for medical diagnosis and also dental X-rays. And the gamma rays emits by nuclear active radioactive materials. Microwaves we use for cooking and reheating of the food and so on. The speed of the electromagnetic waves it depends on two factors. One is the type of the wave, the other one is the nature of the medium. The medium can be air, water or the vacuum. But all the electromagnetic waves, the speed in the vacuum is a constant value, that is 3 times 10 to the power 8 meter per second. So for our calculations we use this constant value as the speed of electromagnetic waves. Let's talk about what is a wave. So last slide we discussed electromagnetic spectrum is the different electromagnetic radiation or the waves. So what is a wave? Wave is an oscillation or periodic movement that can transport energy from one place to another. So this is how the waves looks like. There are three characteristics of waves: wavelength, frequency and amplitude, in addition to the speed of the wave. So what is a wavelength? Wavelength symbol is Greek letter lambda. It is a distance between two consecutive peaks or trough in a wave. For this given wave, you can see two peaks. If you consider the first peak and the second peak, the distance between two adjacent peaks or distance between two troughs, we call the wavelength lambda. So it is a distance. So we can use distance measuring units as a unit of wavelength, like nanometer, centimeter, meter, like that. The second characteristic is frequency. So frequency symbol is Greek letter lowercase Greek letter nu, nu. This is like V. So we can define frequency as the number of waves or cycles that passed within 1 second for a given place. If you pick one place, how many waves or how many cycles pass this place within 1 second. So units are per second or hertz. So 1 per second is equal 1 hertz, or for large frequencies we can use megahertz, gigahertz and so on. The third characteristic is amplitude. Amplitude is if you draw a midline through this wave from midpoint to the peak of the wave, the vertical distance between midline to the peak or vertical distance from midline to the trough, we call amplitude. So these are the characteristics of wave: wavelength, frequency, amplitude, and last time we discussed the speed of the wave. Let's see one example. Rank the following radiation according to the increasing order. So there are 5 types of radiation given: microwave, infrared, blue light, invisible portion, gamma rays, and radio and TV waves. So these 5 spectral regions you need to arrange increasing order of wavelength, increasing order of energy, and the increasing order of frequency. So you need to give 1 for least frequency or least energy or least wavelength, and number 5 for the highest energy, highest wavelength and highest frequency. Energy and the frequency are moving in the same order and the wavelength is the opposite order. Larger the energy, larger the frequency, however lower wavelength. So this should be the order of wavelength, energy and frequency. As among these 5 spectral regions, you can see gamma rays is the highest energy. So it's number 5, highest energy and also highest frequency, but lowest wavelength, number 1. So next highest energy is a blue light in the visible portion of the spectrum, and then blue light has the next highest wavelength. And then infrared region, the microwave region, finally the largest wavelength is in radio and TV waves, and the lowest wavelength and lowest energy in the radio and TV. Let's go and find out some other calculations using the electromagnetic spectrum. Next calculation is the wavelength of the yellow light from traffic signal is centered at 575 nanometers. What is the frequency of this radiation? So here the nanometer value or the wavelength value is given. We need to calculate new frequency. We know the speed of the light, electromagnetic light or the spectral any wave, the light we can consider the constant value 3 times 10 to the power 8 meter per second. So then we can apply this equation. C is equal nu times lambda. C is the speed of light, nu is the frequency, lambda is wavelength. So before we apply the values to this equation, we need to convert the wavelength into nanometers, because wavelength This is another example. Suppose NASA transmit a microwave signal to the space shuttle using radio waves with frequency of 15 megahertz. So calculate the wavelength of these radio waves. So frequency is given 15 megahertz. We need to calculate wavelength lambda, and we all know the speed of this radiation is 3 times 10 to the power 8 meter per second. So first step is applying this equation. C is equal nu times lambda. C is the speed of the light and nu is the frequency and lambda is wavelength. However, before we apply the values, let's convert the megahertz into hertz. Kilo, mega, giga, tera, peta. The prefixes added according to that order. Kilo means 10 to the power 3 times. Mega means 10 to the power 6 times. So 1 megahertz equal 10 to the power 6 hertz. So using this equality, we can build this conversion factor. So 15 megahertz multiplied by the conversion factor, megahertz cancel, 15 times 10 to the power 6. It is 1.5 times 10 to the power 7 hertz. Another unit is per second. Next, we can apply this hertz value, frequency value and the speed of light value to the equation. So C, that is speed of light, is equal, nu is 1.5 times 10 to the power 7 times lambda, wavelength. So if you divide both sides by 1.5 times 10 to the power 7, you can see the lambda answer. It is 20 meters. Thank you all for watching. If this is helpful, please subscribe the channel and comment any specific area if you need to discuss. Now I hope now you will have a better idea about electromagnetic radiation and how we can do some sample problem solving.